Hello everyone, welcome to the Decode NCERT series. Here we are going to help you to understand all the important chapters of physics from NCERT. So I will highlight all the important parts that you have to study from your NCERT chapter. So I request you open your NCERT book and follow me as I say. This is important, then you have to mark it, highlighting it, and whenever you get the time you can read that part. Whenever you are revising the chapter, whenever you are studying the chapter, maybe you are studying the chapter for the first time. So you might be thinking, okay, this is a 60-page chapter, from where I should start and where I should read, and sometimes in between you lost in the wordings and you lost, okay, this is may not be super difficult for me, I will follow something else and I will not study NCERT, which is a very bad thing. So here I will basically highlight you, guide you through the most important aspects of NCERT, where you can start, where you can end, where you just leave it. If you want, you can go through that remaining part at least once, but whatever is important, that I will tell you. Okay, this will not be a teaching video where I will teach in a full length discussion, but I will give you basic ideas and concept clearance. If there is any misconception, that I will tell you in this video. Right, clear? Now, as you may be aware of that, currently we are going through a special PU2 blueprint test series, where we are trying to help you to achieve maximum possible marks in your PU2 exam, and it is already launched 12 test series. 2 of the tests are already happened, and if you want to join, it is not too late. The original cost of this was 599, right? You already know that. So original cost was 599, but if you use my special code, that is SAM100, you will get a special discount. Because you are very special, you will get a special discount, and it is available only for 499. Okay, so 499 is the cost. So this special discount is from me, so you can apply my code, my coupon code SAM100. Hurry up, this is valid till 28th of December, so don't be late. Apply this code now so that you don't miss out on this super opportunity. Right, now let's start with this chapter, electric charges and fields. So first part, up to this point you can ignore everything. Okay, where I have highlighted up to this point you can ignore everything. If you wish, as I said, you can read them once, but whatever you are reading, that is not super important. This is the important part that you have to highlight, that like charges repel and unlike charges attract each other. Even though this is very simple, very easy to remember, but still this is the only important line up to this point. Okay, so that's why even it may seem that, okay sir, this one I already know, but you didn't know that you can skip all those things, right, including the glass wool experiment. Glass wool experiment you can ignore, right. Only the important part or important gist of everything is like charges repel and unlike charges attract each other, which is very simple to remember. Again, up to this point you can skip everything, and you need to remember that this is a very potential target for objective question, that to detect charge on a body, gold leaf electroscope is used, right. So gold leaf electroscope is used. Gold leaf electroscope is a electroscope which is used to measure whether the charge is there or not, right. So this is a device which is used to detect the charge. So this is a source of MCQ as well as fill in the blanks. So fill in the blanks, they will say that to detect the charge on a body, dash is used. So you have to answer gold leaf electroscope, or which of the following is used to detect charge on a body. So they will give you some instruments, you will be confused and you will answer something wrong and you will lose out 1 mark. So gold leaf electroscope is basically to detect the presence of charge. Okay. Now what next? Next is to electrify a neutral body, we need to add or remove one kind of charge. Okay, and since they have not introduced the concept of electron, they are not mentioning what is it. So you should remember in your head, this is these one type of charge are electrons. So either you can add electron to make it negative, or you can remove electron to make it positive. So they have mentioned that in terms of words, that when we say that a body is charged, we always refer to this excess charge or deficit charge. Excess charge means you have added extra electron, deficit of charges means you have removed some electrons. Okay. So only one type of charge can be exchanged, and that type of charge is electrons. So that is why I am here to guide you. They have not yet introduced electrons, but you are already aware of electrons. So why not use this term electrons, right? So that is why I will help you to understand if there is any inner meaning to any part of this book. Now those which allow, now next we are talking about conductors and insulators. So mostly all the basic foundations part, development part is already completed. Now we are into basically defining conductors and insulators. Even though this definition of conductors and insulators are not super important, because the band, in terms of band theory, definition of conductors and insulators are important, that is in semiconductor chapter, but still you should know about this. Maybe there is a MCQ coming from here. Those which allow electricity to pass through them easily are called conductors. They have electric charges that are comparatively free to move inside the material. So why do a conductor conduct electricity? Because they have free electrons. Okay, you have to know that. Maybe they will ask you, conductors conduct electricity because they have free electrons, free protons, bound protons. Actually they conduct electricity mainly because of free electrons. Okay, protons has nothing to do with conductivity. Now there will be we will devise them in our chapter. So they have also mentioned that semiconductors on temperature, with temperature the resistance of the conductor increases, that we will discuss in current electricity chapter. So don't worry anything about rest of the parts, they are being covered in one chapter or other chapter. Okay, even they have mentioned about semiconductors. Now basic properties of electric charge, super duper important concepts. Okay, super duper important concepts. Specifically if you are preparing for PU board, this question is almost asked almost every year. Okay, mention 3 properties of charge, mention 2 properties of charge as a 2-mark question, mention 3 properties of charge as a 3-mark question. So basically there are 3 important properties of charge. I have seen students writing like charges repel, unlike charges attract. That is not a property of charge. Property of charge is this: charges are additive in nature. Okay, basically you can add charges like a scalar quantity, and this example you can remember, this is optional. This part is optional, you can remember it while writing the exam. You can write this example. It is good to know but not must know. Okay, this is a good example. So basically what you are doing, you are just adding them scalar, you can treating them scalar quantities, and you can just add them with their signs. Okay, even though there are a lot of vector quantities involved, right now we are only talking about scalar quantities. So this one you can just remember as scalar quantities. Now charges is conserved. So what is the meaning of charges is conserved? Charges is conserved means the total charge of an isolated system is always conserved. So total charge in an isolated system is constant. Okay, it will neither increase nor decrease. They can exchange the charges between them, but the total charge of the system will remain constant. Okay, that is very important. When you are looking from outside and the system is isolated, total charge is constant. In between, if suppose there are 2 objects, they may exchange charges between them, but the total charge will remain conserved. So like a conservation of momentum. Remember that isolated system, same is here. Now this is where the concept of electron is coming, quantization of charge. All the charges that we see is basically a multiple of the lowest possible charge, that is E, and the charge of any object can be represented by Q equals to NE. So charge is a quantized quantity. You cannot take any arbitrary value. What is the meaning of quantization? As I discussed in my previous lectures, that quantization means it comes as a packet system. Okay, you cannot take half of it, you cannot take 1 and half of it, you have to take either 1 or you have to take 2. So similar to that, milk packet I generally get the example of, because milk packet you can either have to buy the full packet, or you have to buy 2 packets or 3 packets or 4 packets. You cannot say, okay, I want to buy half of this packet, right? half liter is okay, but half liter comes in a full packet, right? So you can buy on the multiple of half liters. That's why it is a minimum amount that you can purchase. So that is the quantum, right? So here that E represents that one packet of milk. Now if there are n number of charges are exchanged, then E is basically the total charge that is the object has gained or lost is basically Q is equal to NE. And also here this line is also important. Okay, charge of an electron is 1.6 times 10 to the power of minus 19, we already know that. And if a body has 1 coulomb of charge, then it must have either this many extra electrons or either this many less number of electrons. Now there is a question, objective question, which comes to my mind is that an object is charged with plus 1 coulomb charge. Okay, understand this. Object is charged with plus 1 coulomb charge. So to do that, we have to, number 1, remove 6 into 10 to the power of 18 electrons. We have to add 6 times 10 to the power of 18 electrons. We have to add any other number of electrons, and we have to add any other third number of electrons. Okay, maybe 3 into 10 to the power of 18 electrons, or 1.6 into 10 to the power of minus 19 electrons. That is very common choice. So you have to remember that when you are saying plus 1 coulomb of charge, that means you have to remove this amount of electrons. Actual term is 6.25. Okay, but 6 into 10 to the power 18 is approximate value, which is very close. So you can use that value as well, but you should remember that you have to remove this many charges. That is important. You cannot add. If you add them, it will be minus 1 coulomb charge. So the question is very common and often asked in all of the question papers. It may be in your PU board exam, maybe in your KCET exam. In KCET exam, they will not give you direct 1 coulomb charge, they will give you 1 nano coulomb charge or 1 micro coulomb charge. Okay, so that you have to adjust that 10 to the power of minus 6 factor. So whatever charge they have given, you have to multiply that factor with this. So 1 micro coulomb means 10 to the power of minus 6. So you have to multiply this with 10 to the power of minus 6. So it will be 6 times 10 to the power of 12 number of electrons. Okay, so that factorization you have to take account for if it is asking, if it is asked in KCET exam, but in PU board exam most time it is asked as 1 coulomb or plus 1 coulomb or minus 1 coulomb. Clear? If you have any doubt, you can mention that in the comment below. I will try to address them while checking the videos. If there is any comment still left, I will check that. Okay, now this is a problem I recommend only to understand how you can solve numerical based on the concept that what is the total number of how to calculate the time or charge or whatever it is. Okay, so 10 to the power of 9 electrons are moving from an object in 1 second. What is the time required to gain 1 coulomb of charge? So basically it gives you an idea that it approximately 200 years. So 200 years it will take to gain 1 coulomb of charge, despite a huge amount of electron is getting lost in every second. So 1 coulomb charge is a huge charge. That's why this problem I tell my students to see it at least once, so that you get the idea that 1 coulomb charge is not a small charge, it's a huge charge. It's even though it's 1 micro coulomb, nano coulomb are more common than actual coulomb, because coulomb is a huge unit. Okay, now Coulomb's law statement, you know the Coulomb statement that you can write, or if you want to write, no, I only want to write the Coulomb's law from NCERT, then this is the statement. Okay, they have started with distance first and charges later. Okay, but you can write the charges first and distance later as well, but you have to mention one thing that I will say. It varies inversely square with the distance between the charges and was directly proportional to the product of the magnitude of the charges, and this force acts along the line joining the two charges. This is very important. This point I have seen 80% student misses. okay, 20% students only write this line. This line is also important, and the formula is obviously F is equal to K Q1 Q2 by R square. K is Coulomb's constant. Also sometimes we write this as K is equal to 1 by K equals to what? 1 by 4 pi epsilon naught. We'll see that. Also the unit of K is Newton meter square per Coulomb square. From here you can find the unit of epsilon naught as well. Now basically K and epsilon naught are inversely related, so you can say that, okay, if the unit of K is Newton meter square per Coulomb square, then epsilon naught's unit is Coulomb square divided by Newton meter square. So this is the unit of epsilon naught, very important to remember. If you recall, in your first few final exam, there was a question on what is the unit of G, okay, and in the problem section there was a numerical question there, they have given you the unit of G as well, but still I found few students miss out on that and they still have made mistakes. They wrote that answer incorrectly. What to do? If you read the entire question paper, you should have been able to answer that question. Even if you have made a mistake, you should read the, because the students didn't read the numerical. They know that, okay, I have not studied at all in the class, I will not be able to solve the numericals. They skipped the numerical altogether, but in the numerical question the unit and value of G was given. So if you had read the question paper properly, then they would have written that answer properly. That is what. I know many of you are still afraid of numericals, but still you have to read the question paper. And so see my Brahmastra series where I am doing numericals every day. Not super too many numericals, but sufficient number of numericals are done in the class, so that you can get that confidence and solve those numericals. Now this is the diagram that is required for vector notation of Coulomb's law. This diagram is compulsory. Okay, diagram is compulsory, you have to write this diagram, and vector form is this. Okay, I don't want to explain the terms. You can find the terms. What is this terms? This is written somewhere here, but this equation you have to write, and at the end you have to write F12 equals to minus F21. Okay, F12 equals to minus F21. Also one more thing, in all throughout this book, okay, they have mentioned all the vector quantities are mentioned in bold letters, but in your exam you cannot use bold letters, so you have to use this cap. Okay, here it is cap already, no problem, but otherwise whenever you are seeing a vector you have to use this arrow. Okay, don't miss out on that. I have seen students after writing this ditto, they have memorized this from the NCERT book, and they wrote it as it is given in the book, and they say, sir, in the book there is no arrow, why should I give arrow? I said, in the book this is a bold letter, you are not used bold letter, all of your letters are same, and you cannot possibly write bold letters in your answer sheet. Okay, either you have to use faint letter and bold letter, so your faint letters will not be readable properly. So if you see, they have this facility and they are using it, because to add an arrow it will cost some extra amount of money, so the printing cost will increase. Instead of that, they have taken the shortcut way, and many publishers actually take this bold letter route. There are very few publishers, very few authors, they use arrows. Arrows are more better way to represent a vector, even though this is the correct representation, this is not wrong at all, but still arrows are good for the students who are going to write this in the exam, right? Now you can read these points one by one. Okay, Coulomb's law gives the force between two charges, etc., but that is not super important. Okay, this line is important for KCET. Okay, if the charges are placed in a matter, or the intervening space has matter, okay, the law gets complicated to the presence of the charge constituent matter. We shall consider the electrostatics in this matter in the next chapter. So even though they have said that next chapter, okay, the formula sometimes is important. What happens to the force between two charges if you keep a dielectric medium between two charges? Okay, they will not discuss this in detail in the next chapter, but this part you should know. Okay, if you have interest, I have done that in my KCET class, you can check that out. Okay, now force between multiple charges. Now we have multiple charges. Okay, there are Q1, Q2, Q3, and we want to find the force on, say, this charge Q1 due to all these other charges. Okay, this is Q2, this is Q2, and this is Q3. We want to find the force on all the on this charge. This is my primary charge, and these are the charges which are pushing it. So you are the target and your friends are pushing it. So how with what force you will move? What is the force acting on you? So that is, this is you and these are your friends. They are pushing you. They are someone may be pushing you, someone may be trying to pull you back. So that's how we have to do it. We have to calculate the vector sum. Okay, remember that vector sum is important. Force on any charge, the number of other charges in the vector sum of all the other forces acting. So force on any charge due to the number of other charges is the vector sum of all the forces on the charge due to the other charges taken one at a time. So you cannot obviously take all the charges simultaneously, right? So you have to take, suppose Q1. So first you will consider Q1 and Q3. Next you will consider Q1 and Q2. Then you will add them vectorially. That is important. Vector addition is important, and since you cannot consider all of them at a time, you can add them one by one. So here they have given you the formula. Okay, you can see that Q1 Q2, Q1 Q3, Q1 Q4 dot 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 Q1 Qn. So Q1 is our primary charge, so that's why Q1 is common for all the equations, and with Q1 all the other charges are getting multiplied except Q1, right? So this is how you calculate the total force. This is a thing to know about when you are solving numerical problems. Okay, there will be some numerical problems where you might need to apply this concept. That's it. Now electric field. So the electric field formula is very important. Electric field, now we are not using Coulomb's constant. We have moved into 1 by 4 pi epsilon naught. Okay, and it is given by Q by R square. It is also inversely proportional to the distance, and not only that, there is only one charge here because electric field is due to only one charge, right? And the force due to electric field, if you keep a second charge in the electric field, then that force is basically Q into ER, that is Q times magnetic electric field. So force on a charge is basically Q into electric field. This is a super important concept. Okay, in problem solving in future chapters, everywhere we are going to use this formula. This is super important. Okay, so there was a question in a numerical question, two charges are kept at a distance. Okay, what is the electric field at the middle of them? Then you have to use the formula of superposition to calculate the electric field at the middle of them, and then they will say if we keep a 2 nanocoulomb charge at this point, what is the force acting on it? So after calculating the field, you have to multiply it with the charge given to calculate the force acting on that charge. Okay, now you can ignore everything in this part. For a positive charge, the electric field will be directed radially outwards from the charge. For the negative charge field vector, the each point points radially inwards. So this is like electric field lines. We will see that in a while. So electric field for a positive charge is outside, going outward, and for a negative charge it is going inward. This is all the important things. From this you can ignore all this part until this part. Accelerated motion of charge produces an electromagnetic waves. Okay, so when the charge is accelerating in an electric field, basically that produces electromagnetic waves, which then propagate with the speed of light to reach Q and cause a force on Q2. So basically what is happening, two charges are kept. So if I there is a charge, there is an electric field, right? And if I put another charge Q2 here, then how quickly this force will exert the force on this new charge? Will it be instantaneous or it will take some time? So the information to reach this charge, that okay, there is a new charge is present, is basically will travel at the speed of light. Okay, even though there is no physical significance, the thing is that if this charge was accelerating, then there would have been an electromagnetic wave. So the main takeaway from this line is that accelerating charge can produce electromagnetic wave, even though we will learn about that in electromagnetic wave chapter, but you should remember this fact as well. Now next, yes, you can skip everything. So you can see that you can skip most of the book, which is full with some lines. If you are super physics enthusiast and you want to score out in physics, not only that, you want to score out in JEE Advanced, you want to study physics in higher level, then you can finish the book. Otherwise, no need. I am here to guide you what all are the important. So there are the properties of electric field lines. These 4 properties are important. So there are either 3 or 2 will come. So you have to remember 3 or 2. Okay. So what are the main points? Field lines start from positive charges and end at the negative charges. So basically this is the same way we said electric field, property of electric field. So electric field is radially outward for positive charge and radially inward for negative charge. So this is a positive charge, right? This is a positive charge and this is a negative charge. So for positive charge it is radially outward, for a negative charge it is radially inward. So the electric field line starts at positive charge and end at negative charge. If there is only one charge, single charge, okay, they may start or end at infinity. If there is only one charge, then the electric field lines can start at infinity and come to this point. For example, here this is a negative charge, right? Where do these lines coming from? This line is coming from infinity and they are reaching to the negative charge. Similarly here, if you consider this charge, this is an isolated charge, where these field lines are going to, these field lines are going to infinity. Okay, infinity is their home, so they are going to infinity. Now here they have stayed in infinity for a long time. Now they are coming to visit this charge, so that's why they are coming to negative charge, right? So they can go to infinity at their own will and they can come back from infinity at their own will. Okay, as long as this charge is what it is, right? Both charges, now here you can see both charges are positive, both electric field lines are going to infinity. So if the one type of charge is there, then they can go to infinity or they can start from infinity as well. Now in charge free region, electric field lines can be taken to be continuous curves without any breaks. So if there is no other charges present, where there is no other charges is present, during that line you can see this is a continuous line. Is there any breakage here? There is no breakage, it is a continuous line, right? So charge free region means anywhere there is no charge, but you cannot apply that here. There is a charge present, right? So you cannot apply that concept here. So as long as there is no other charges, you can consider this to be a continuous lines without any break, right? Next is, two field lines can never cross each other, because if they did, then at the point of intersection there will be two direction of electric field, right? Electric field lines are basically, if you draw the suppose there is an electric field line, and if you want to find the direction of electric field at any point, then you just need to draw the tangent at that point, right? So tangent at any point represents the direction of electric field at that point. Now if two field lines suppose has to consider coincide, okay, or intersect each other, then at this point of intersection one field is along this direction, another field is along this direction. So electric field will have two different directions, which is not possible. In detailed explanation I have done in my KCET class. I am not going to discuss super detail, because in your lecture, in your book also it is not discussed. So I am not going to discuss in detail about that, but you can check my KCET video for detailed answer for this, right? Two field lines can never cross each other because they will have two different direction. Electric field lines do not form any closed loop. This follows from the conservative nature of electric field. So electric field is a conservative field and they do not form any closed loop. What is the meaning of closed loop? Closed loop means if they start at the same point and end at the same point, then we say that there is a closed loop. This is a closed loop. But for electric field this is not possible. Okay, it is not possible for electric field. It can go like this, it can go other direction, okay, and it is very important to draw the arrows to show the direction, but they will never come and cross each other. They will never ever be closing each other. In other case, magnetic field lines are closed loops. We will see that in magnetic field chapter. Now, electric flask, here I have slight disappointment with the NCERT book. The concept of electric flask should have been given just before Gauss's law, but it is coming abruptly somewhere in between without any context, without any proper linkage between the concepts. Okay, they have just linked it with field lines, but that is also not super good in a way. Okay, so electric flask is basically how many number of lines are passing through a given surface area, perpendicular, how many field lines are passing perpendicularly to a given surface area. So, flask is change in flask is basically given by E dot delta S. Delta S is basically we consider a small surface area. So, small surface area is given by E dot delta S. Now, what is the total flask? Total flask is you have to consider all such small areas and add them. And why we do that? Because not all the surfaces are regular surfaces. If it is a regular surface, this equation can be converted into an integration. Okay, if we know the surface, then it can be converted into integration E dot ds. That is what we do in case of Gauss's law, right? That is what we do in case of Gauss's law. Summation becomes integration because sum and integration are brothers. So, you can convert them, right? Now, so that is the basic idea that you need to take away from this part. Now, electric dipole is super important concept, okay, and there are two derivations that you have to do. First of all, you have to remember what is electric dipole. Electric dipole is a pair of charges plus q and minus q at any point in the space can be find out from Coulomb's law. Now, there are two positions for points on the axis and for points on the equatorial plane. Both derivations are super important. You can follow my Brahmastra series for these derivations, or you can follow this textbook for this derivation, but in this textbook they have defined this term dipole moment at the end, and they have done both of them one by one. So, this is the electric field due to a dipole, right, and they have linked them at the end where they are talking about electric dipole due to on the axis, on the plane, and they have linked these two concepts here. So, this is the final answer. You have to remember, if you leave the answer here, their teacher will deduct 1 mark for that, because in the textbook they have done this together at the end. And so why they have done this together at the end? The main reason is to compare them easily. That is the main reason. The book is not super student friendly. That is why students struggle with the NCERT book, because after this, this should have been come. After this should have been come, so that student can understand, okay, this is the part I have to write in exam. But that is why NCERT is not super student friendly, specifically in terms of exam perspective, but it is a good book to understand if you are studying, if you are a studious student. But for normal regular student, NCERT is not super good. They struggle to write from NCERT. That is why they take help from teachers like us. Obviously, we are experienced teachers, we are here to help you as usual. Now, E is equal to 2p by 4 pi epsilon naught r cube. So, basically as you can see, what is the relationship between this and this. So, this is along the axis. So, E axis is basically negative of 2E perpendicular. Okay. So, if you add this value, if you see, this is the this is not only half of that, this is also negative sign. So, they have a opposite sign from each other, because for this E and P are in the same direction. E and P are in the same direction, but in this case E, suppose in this direction, P will be in the opposite direction. And what is the dipole moment? Dipole moment, I think I have not highlighted it. So, dipole moment is also an important concept. Okay. This is also important concept. Okay, and its direction is from negative to positive charge. Okay, from negative to positive charge. So, this is also important to understand. Okay, dipole moment is basically what is the value of dipole moment and what is the direction of dipole moment, right. Let us move on. Physical significance of dipole. So this part we will study again in our next chapter, but you have to understand that in most molecules the centers of positive charges and negative charges lie at the same plane, therefore their dipole moment is 0. CO2 and CH4 are this type of molecules. In some molecules the centers of negative charges and positive charges do not coincide, therefore they have a permanent electric dipole moment even in the absence of electric field. Such molecules are called polar molecules. So we will learn about them again in the next chapter, but you have to remember these lines are important for MCQ questions and fill in the blanks question. Okay. Let us move on. Dipole in an external electric field. There is a small derivation related to dipole in an external electric field. The torque acting on a dipole is basically given by P cross E. This derivation you have to practice, okay, and this diagram is compulsory to for this derivation. So that is why this is important. Now let us move on. There are three types of charge distribution: continuous charge distribution, surface charge distribution, line charge distribution, and volume charge distribution. So if you have a surface which is not regular, you want to find what is the electric field due to that surface area. So in that case, knowledge of total charge is not always helpful. So what is helpful is that charge density. So if the charge density is uniform, sometimes we prefer charge density above total charge in that object, okay, and these are the basic three definitions. So if you take a small area, calculate the total charge in it and divide that charge with that area, then you get the surface charge density. Similarly, if you take a small length, measure whatever charge in that length and divide the charge with that length, you get that line charge density. Similarly, for volume, you take a small volume, calculate the total charge, divide that charge with that volume, you get the volume charge density. It is helpful for mathematical processes. Next is Gauss's law. Okay. So Gauss's law is basically, we all know that Gauss's law statement, formula, etc. So this is basically that's what, and here I think I have not highlighted the Gauss's law statements. So electric flask through a closed surface is basically Q by epsilon naught, right? This is the Gauss's law. So that's why this is also important. And one more form that you have to remember for Gauss's law is flask is equals to Q enclosed by epsilon naught. And what is flask? Flask is basically integral E, close integral E dot ds equals to Q n by epsilon naught. These two are forms of Gauss's law that you also have to remember. These two forms are not explicitly written, so that is why I gave you. Now Gauss's law is the true for any closed surfaces, no matter what is its shape and size. So does not matter, some say Gauss's law is only applicable for spherical objects, Gauss's law is applicable for rectangular object, but it is actually applicable for any objects, okay. It can be any random object, as long as it is a closed surface it is applicable, okay. There is a specific case, even though the surface was closed, it was not considered to be closed, that is Mobius strip, that we are not discussing in here. The term Q on the right side of the Gauss's law includes the sum of all charges enclosed by the surface. The charges may be located anywhere inside the surface. So charges can be located anywhere inside the surface, is not necessarily to be at the center only. Okay, some people have a misconception that charge is located only at the center. Charge can be anywhere inside the surface. Okay, it does not matter, but this formula, this law is still valid. In situation when the surface is so chosen that there are some charges inside, some are outside, the electric field whose flask appears on the left hand side is due to all the charges, both inside and outside S. Some charges are in this, suppose we have some charges which is inside, some charges are outside. The formula that we mentioned, that this electric field that we have mentioned here, this electric field is due to all the charges, but this one Q enclosed is only for the charges which are inside. That is the beauty of Gauss's law. Okay, if you choose the Gaussian surface such that some charges are inside, some charges are outside, then Gauss's law is applicable for this system as well. Electric field will represent total electric field, but the charge enclosed will represent only the charge which is inside the surface. Okay, the surface that we choose for application of Gauss's law is called Gaussian surface. Gauss's law is often useful towards a much easier calculation of the electrostatic field when the system has some symmetry. So, Gauss's law is practically more viable when this is a symmetrical surface. We have 3 applications of Gauss's law, which is important. Out of that, 2 is important. One, the formula you need to remember. First one is field due to an infinitely long straight wire. This is the derivation for that. Okay, you can remember the derivation. This diagram is important. This is the diagram, not this one. This diagram is important. Okay, and you have to read it once to understand what you have to write. What is these variables? You have to mention the variables names, right? Where n is etc. This is the just part of derivation. Okay, you can practice it from here. And this one, field due to an uniformly charged infinitely plane sheet, this is not important, only its formula is important, and as you can see, this formula is independent of total charge. So, this only depends on the charge density. Charge density is basically constant for uniformly charged object. So, electric field you can consider to be a constant, right. So, this is one interesting fact about charge sheet. Okay, infinitely long charge sheet. If it is not infinitely long charge sheet, then this formula is still valid close to the surface. Okay. Field due to a uniformly charged thin spherical shell, that is very important. Field outside the shell is basically this form, and this form is nothing but, if you can consider, all the charges on the shell is located at the center of the shell. So, that is what this is like a point charge you can consider, but that is only for field outside the shell. For field inside the shell, there is no electric field inside the shell. So, electric field inside the shell is 0. We already know that, as it does not includes any charges. So, this is the main crux of this entire chapter. You can read all the concepts at least once, or you can skip that, that is completely up to you, but whatever I have discussed here is must read, have to understand, and for more detailed understanding you can check my Brahmastra video, you can check my KCET video. Okay, I will be back with a new chapter on Friday. Till then, bye.